Hello friends, in this video we will study about some of the features of the 8259 IC, which is also known as the Programmable Interrupt Controller, or its short form is PIC. So let's start with our topic. So we are going to study about the Programmable Interrupt Controller PIC, whose IC number is 8259. Now we know that the 8085 microprocessor, it has 5 hardware interrupt pins, and these hardware interrupt pins are trap, RST 7.5, 6.5 and 5.5 and INTR. So if we write here in 8085, 5 hardware interrupt pins are there, and these 5 hardware pins are trap, RST 7.5, 6.5 and 5.5, and we have INTR. So these are the 5 hardware interrupts in the 8085 microprocessor. Now out of these 5 hardware interrupts, the 4 hardwares interrupt trap, 7.5, 6.5 and 5.5, they have the interrupt vector addresses, or we can say that these 4 interrupts are the vectored interrupts. Vectored interrupts because for the interrupt service routine which is written at some memory location, that address is known for these interrupts. Like for trap, we have the address. So these are the addresses where of the memory location where the interrupt service routine is written. So whenever these interrupts are given to the microprocessor will jump to these memory locations, and at those memory locations instructions are written, subroutine is written, so that subroutine will be executed, and again the microprocessor will continue to perform its main task. Okay, so we can say that out of these 5 hardware interrupt pins, 4 hardware interrupt pins have addresses for their interrupt service routine, whereas this INTR, this interrupt is a non-vectored interrupt. Non-vectored interrupt because its vector address for the interrupt service routine is not known to the 8085 microprocessor. So an external device is needed which will provide the vector address for this INTR interrupt. Okay, and this external device will tell the microprocessor that what is the type of the interrupt which it has to execute and what is the address where the subroutine is written. Okay, so this external device will provide the type of the interrupt, like the type of the interrupt related to it is from RST0 to RST7. These are the restart instructions in the 8085 microprocessor which are executed through this INTR interrupt request signal. Okay, this interrupt, when this interrupt is given, then these instructions will be executed. Okay, so this external device, it will provide the type of the interrupt and also the interrupt vector address. So that becomes the function of the external device, that it has to provide the type of the interrupt and interrupt vector address to the 8085 or to the microprocessor, we can say. Okay, so that is why there is a need of a device which will tell the microprocessor these things. Okay, now let us come to the applications, like where several number of input output devices, they want to communicate with the microprocessor. So when there are number of input output devices, then, and all the devices, they want to transfer the data to the microprocessor in the interrupt driven data transfer mode. So in this mode, whenever any input output device it want to communicate with the CPU or the microprocessor, it is going to interrupt the microprocessor, that I want to transfer the data and then communicate with me. Okay, so if I say here that this is the microprocessor, suppose 8085 is there, and there are several input output devices. Now each of these input output devices, they want to communicate with the 8085. So when these input output devices, they want to communicate with the 8085, then they are going to send an interrupt request to the 8085, that I want to communicate with it, or I want to transfer the data to you. Okay, now this 8085, it has to decide that which of the input output devices it want to first communicate. Okay, because there are many input output devices, it has to check the priority, that which of the input output device is having the highest priority. So I will first communicate with that, and then according to the priorities, it is going to transfer the data, or it will communicate with the input output devices. So this 8085, it need to check the priorities, and also it wants to have the interrupt signal from all these input output devices. Okay, so the 8085, this microprocessor, it becomes busy in this task to check the priorities, to communicate with the all these data. So rather than becoming busy in this task of checking the priorities and communicating with these input output devices, it uses a device which is known as the 8259 Programmable Interrupt Controller, which controls all the interrupt operations of the microprocessor. So that is why the need of an external device arises, and this need is fulfilled by developing a controller, Programmable Interrupt Controller 8259. Okay, so this 8259, which is known as the Programmable interrupt controller, it controls all the interrupt operations of this 8085 microprocessor when it is communicating with multiple interrupt systems, like where it is having multiple interrupts, then we can use this 8259 IC, this programmable interrupt controller. Okay, so in this video, we are going to study about some of the features of this Programmable Interrupt Controller, or PIC. So if we talk about the features of this PIC, its first use is that it is used to handle all the interrupt operations of the microprocessor, or we can say that it is used to relieve the microprocessor from the task of checking the priorities and handling the multiple interrupts. Okay, So this controller, it takes care of a number of simultaneously occurring interrupts. Request means when there are many number of interrupt requests which are occurring at the same time. So that type of interrupt request can be handled using this controller. And also the type of the interrupt request means which type of interrupt is provided by the input output devices, the type, and also the priority, that which interrupt is having the highest priority, which is having the lowest priority, and that is also decided by this controller. So this controller takes care of the multiple interrupts which are occurring in the processor. Okay, so this controller, it is basically relieving the microprocessor from these tasks. Okay, now this programmable interrupt controller, whose IC number is 8259, also known as PIC, this controller, it can handle 8 interrupt pins. Okay, so 8 input output devices which are sending 8 interrupt requests to the microprocessor, they can be handled through this 8259. So here if we have the microprocessor 8085 or any type of microprocessor is there, so we will have this 8259 which is connected between the 8085 and the input output devices. So here we can have 8 input output devices, and this 8259, it has 8 interrupt pins. Okay, so 8 interrupts can be handled, or interrupt request can be handled by this 8259. And this is similar to, like earlier we were having for 8085, we were having the INTR line. Okay, here we were having interrupt request line. So only one device can communicate with 8085. But if we are using 8259, then 8 interrupt pins or 8 interrupt requests can be handled by the 8085. Just this 8259, it will decide the priority, that which interrupt request is having the highest priority, so that interrupt request will be first accessed, then second, then third. So in this way the priority is decided. But if 8259 we are not using, then there we will be having only INTR, and in case of 8086 we have the INT line. So only one interrupt request can be handled. But with 8259, it can handle 8 interrupt lines. Okay. So this is one of the feature of this PIC. Now the second feature is that this 8259, it can be used with any type of microprocessor system like 8080, 8085, 8086, 8088. So all the versions of the microprocessor it can work with. Okay. So here we can write that 8259 can work with 8080, 8085, 8086 and 8088. Now this 8259, it was the older version. The new version is 8259A. Now the difference between 8259 and 8259A is that 8259 can work only with 8080 and 8085, whereas 8259 can work with any of these 4 type of microprocessor systems. With 8086 and 8088 it can also work, 8259 it cannot work. So that is the only difference between the two versions. 8259A, it is an updated version, or we can say it is a higher version of 8259. Next feature of 8259 is that in 8085 microprocessors we have the vector addresses. Okay, and that is the problem we discussed, that when we are having the INTR line, then the interrupt vector address is not available. Okay, and if we see the addresses, if we see the addresses of the so if we see the addresses of the interrupts which are there in the 8085, I have told that you that trap RST 7.5, 6.5, 5.5, they have the interrupt vector addresses which is already fixed. But for INTR, the 8085 needs some external device which is going to provide the interrupt vector address. Okay, now if you see the addresses, you can see that all the addresses or all the interrupt service routines, they are written on page number 00. Okay, this 00, it is showing the page number, and this 243C, 342C, it is showing the column number and row number. Okay, so this, all these interrupt service routines, they are written and on the same page 00. Okay, but if we are and this address for this INTR, it is provided by the external device, and this external device is our PIC, the Programmable Interrupt Controller. Now, this Programmable Interrupt Controller can set the address of the interrupt request on any memory location. Okay, for 8085, we have, suppose we are having the memory locations from 0000 to FF. This is the complete memory locations of 8085. Now this 8259, it can place the interrupt request, or it can write the interrupt service routine at any of these memory locations. Okay, but for the trap RST 7.5, the service routines, they are written on the same page. So that is the use, or that is the speciality of this 8259 programmable interrupt controller. So I can write the feature of this, that the 8259 chip So this 8259 chip, it can vector an interrupt request anywhere in the memory map from 000H to FFFH in 8085 microprocessor. So anywhere in this memory map, the vector request, it can the interrupt request, it can be vectored, or its service routine can be written at any memory location between this 000 to FFFH. Now this is eliminating the drawback that in the case of trap and RST 7.5, 6.5, the service routines, they are written at on the same page 00. Okay, now when the 8085 microprocessor, it is dealing with multiple interrupt systems, where it is where it want to communicate with several input output devices, and all the input output devices, they want to transfer the data in the interrupt data driven transfer mode. Okay, so when multiple interrupt systems are connected, then microprocessor has to decide the priorities of the interrupt, that which interrupt is having the highest priority and which is having the lowest priority, so that in the priority order of the interrupts, their request will be accessed by the microprocessor. Now this task, when we are using the 8259, the 8259, it is going to decide the priorities of the interrupts. So the microprocessor, it is free from this task. So that is the feature of 8259, that it can decide the priorities among the interrupt requests, the 8 interrupt requests which are given to the microprocessor. So 8 interrupt pins can be connected to 8259. So we can say that it can resolve 8 levels of interrupt priorities in a variety of modes. There are various types of modes of operation of 8259. So according to the modes of operation, the priority levels can be decided. So it is the feature that it can resolve 8 levels of interrupt priorities. Now, uh, these priorities, they can be changed when the interrupts request, they are being accessed by the microprocessor. Means when the microprocessor, it is executing the service routine of an interrupt, at the time of execution of the service routine also the priority of interrupts can be changed. Means running status of the priorities can also be changed. Like if we are running a interrupt, if the microprocessor, it is running an interrupt which is having a highest priority, and in between the execution of its service routine, the interrupt which is having the lowest priority can also be accessed. Okay, so in this way, this 8259, it can change the priority of the interrupt at any level. Okay, at the time the service routine is executed, at that time also the priority can be changed. So the priorities of interrupts, it can be changed under running condition also. Now next feature is interrupts. We can say that in case of 8085, we have also studied that the interrupts can be masked. Okay, means if there are several interrupts which are simultaneously occurring at the microprocessor interrupt pins, so out of those, like 4 interrupt requests are given, one of them can be masked. Okay, so this masking and unmasking of the interrupts, it can be done through this 8259 IC also. And this masking of interrupts is done individually. Means the masking is not of the interrupts, it is not interconnected, that if this is masked, this interrupt is masked, then other interrupt, it can also be masked. Okay, so this masking and unmasking of interrupts, it is independent of each other. Okay, and every interrupt can be masked individually. So through 8259. So just like the interrupts of the 8085, the interrupt request through this 8259, it can also be masked individually. Now when multiple interrupts are given to the microprocessor, then 8259, suppose there are 4 interrupts and it is executing one interrupt, and one interrupt will be pending, and one interrupt will be masked. So the status of the interrupt, that which interrupt is currently executed by the 8259, which is pending, and which of the interrupts are masked, all these status of the interrupts, it can be read at any time by the microprocessor if we are using this 8259 PIC controller. So the status of pending interrupts, Or in service interrupts means the interrupts which are currently being executed by the microprocessor, and the masked interrupts, the interrupts which are masked, that when the first will be executed, then the second will be executed. Okay, those interrupts are masked interrupts. Okay, they can be read at any time by the microprocessor, and that is the one of the feature of 8259. Now, when we were studying the 8085 interrupts, you would have remembered that the 8085 interrupts, they can be either level triggered or edge triggered. Some of them were level triggered and some of them were edge triggered. Okay. Now, for those interrupts, if triggering, if it is a level triggered, then only the level of the clock cycle, means either high level or low level, it can trigger the interrupt. And if it is an edge trigger, then only that, when this edge of the clock cycle is provided, then only that interrupt will be given. Okay, but if we are using this 8259 IC, this PIC controller, then the interrupt request, they can be programmed either as an level triggered or either as a edge triggered. Okay, so both type of triggering can be provided to the interrupt request using this 8259. But if we are using 8085, then means if we are using simply the microprocessor, then we have to provide the triggering which is specified for that interrupt. If the interrupt is level triggered, then we have to provide level triggering. If the interrupt is edge triggered, then we have to provide the edge triggering. Okay, but 8259, it can program the interrupts either as a level triggered or as an edge trigger. So this triggering, it is decided by the 8259. There are various modes of 8259 in which the triggering is decided. Okay, so here we can write that the 8259, so this 8259 PIC controller, it can be programmed to accept the interrupt request either as level triggered or edge triggered. Whereas in 8085, the triggering is decided either a level or either a edge. Okay, that is decided for the interrupts. Now with 8259, we have the facility that I have said that 8259, it can handle 8 interrupt pins. Okay, means 8 interrupt requests can be handled at one time. Now if more than 8 interrupt requests are we want, then how we are going to do this? We can cascade, means we can connect more than 2 8259 ICs, and if we are connecting, suppose we are connecting 9 8259 ICs, then we can handle 64 interrupt requests at a same time. Okay, but if we are using only one, then 8 we are using, like if it is 1 8259 IC, so it is going to handle 8 interrupts. Okay, now if we want 64 interrupt request, then we are going to connect 9 8259 ICs. Okay, 8 8259 ICs will be the slave ICs and one will be the master IC. Okay, so in this way 64 interrupt requests can be handled at a, by using the cascaded version, means by using 9 8259 ICs simultaneously. So if required, 9 8259 So if it is required, then 98259 ICs, they can be cascaded in a master slave configuration to handle 64 interrupt inputs. And in this configuration, 8 ICs will act as a slave ICs and 1 will act as a master ICs. So the input output devices which are sending the interrupt request, they will send their request to the slave 8259, and those slave 8259, they are going to send the request to the master 8259, and this master 8259 IC is then going to give the INTR request interrupt request to the microprocessor. Okay, so the master 8259 IC, it can directly send the request also, or it will accept the request from the slave ICs, and then it is going to give the request to the microprocessor. This we will discuss in detail when we will study the modes of operation of 8259. So these were some of the features of 8259 programmable interrupt controller, which is also known as PIC. We studied that this interrupt controller, it controls the interrupt operations, like it decides the priorities of the interrupt, and it also provides the type of the interrupt, the vector addresses to the microprocessor. Means this interrupt request line INTR, the address of the interrupts will be provided by the 8259. So this 8259 can be used whenever the microprocessor, it is handling a multiple interrupt system. Okay, so I hope that this topic is clear to you. Thank you.